All right, again, thank you everybody who's made it to our webinar today. I'm so excited to be able to get this chance to host, one of my idols and MVPs in the space of data warehousing and just data solutions all up, Mr. James Serra. I've been following you on Twitter, your blog, and for those that are attending, if you haven't found his blog before, that is the link. I will have, well, the chat's closed, so we can't post it in the chat. It's just jamesserra.com. Find his blog there. My name is Greg Petrosian. I'm the Director of Sales at CSG Pro and Skypoint Cloud. Talk a little bit more about our organizations as we get into it. You can find me on Twitter, typically posting about Power BI, Azure, data solutions, data architecture, lots of topics that I just geek out on. But data mesh and data fabric has been one that I'm still figuring out, scratching my head, and trying to really find, what is the value in the use cases that really help drive the decision for data mesh. James, anything you want to add? Did I introduce you well enough?
I would say that's a fine job.
If only I had like trumpets playing or like Jeopardy music blaring, but for the next one, because we'll do this.
Marching band behind you, that would be nice next time.
Yes, yeah, we'll get it going. So just a quick plug for CSG Pro. We have been data solution experts since '93. Been working in the data warehousing space for a long time, and have seen a lot of architecture and marketecture evolution in the data warehousing space. For us, traditional data warehousing has been our bread and butter. All types of BI and analytics solutions that we've been around for. So if your organization is looking for help in this space, please reach out to me. I will also mention Skypoint Cloud. We are a customer data platform. And given the way that our platform works, where you bring in data specifically about a customer, we do a lot of identity resolution there, and then push that data out to whether it be your data warehouse, activation tools like marketing automation, what have you. That is what our customer data platform is here to do. If you'd love to learn more about Skypoint Cloud, please reach out to me. This is a quick slide on how we bring data in, do the processing through our platform, and then enable that data and push it out. Much like what data mesh and data fabric are proponents of. So with that, given my background with CSG Pro, as well as the goals of our customer data platform, the questions I had that led to getting this webinar together with James was, first off, what is data mesh or data fabric? Can we get an accurate definition here? Also, what is the differences between this data mesh, data fabric architecture and what we're used to in traditional data warehousing? Then when does it make sense or when does it not make sense to implement this architectural decision? And then, what are the scale and cost considerations? I feel like as we have more data volume, data cleanliness issues and velocity, this being able to scale whatever data platform and architectural decision you make, it's really important. And so you want to be wary of what path you go down. And more advanced considerations I had are, what are the specific data domains that make the most sense for this type of architecture? And where does a platform like ours for Skypoint Cloud, this customer data platform, where does that fit in this whole mix? And so with that, we are going to give this poll capability a try. I would love to hear what everybody's familiarity is with data mesh. Have you ever heard of this before? Is this a new topic? Did you do some researching before you got on? Love to get your idea. What you can do is just go to the poll question. I've seeing some live answering here. Kind of. I have heard of it. It's in the top place. We've got some no, I'm new to this topic. Now, nobody is yes, I am familiar. So don't worry, I'm in your same category. All right, we've got 16 responses. Awesome. 17. Thank you, everybody. I think the crux of it is we're all here to learn, James. So we're going to just follow your lead, and I will let you take over the presentation.
All right, awesome.
Let's stop sharing.
there we go.
And I will mention, for those that are wanting to submit questions, yes, the Q&A is working and open. If you would like to submit your questions as they go, I can, if it is relevant, I will bubble it up to James. But for the majority of questions, we'll save it till the end. And if we have time for that Q&A, if we run out of time, we will follow up with answers or look to do more of a live Q&A session together in our next webinar. So thank you.
Yeah, awesome. And I'll try to leave a few minutes at the end for top questions.
Awesome.
So what I'll cover today is what exactly is a data warehouse, just kind of level set on that, a little bit of a history of the data warehousing. Why do we have data lakes? What are they and how do they compare to a data warehouse? And then we'll get into some of the data architectures that you may or may not be familiar with: the modern data warehouse, data fabric, the data lakehouse, and then the data mesh. There's a lot of these buzzwords going around, especially the data fabric, and I find a lot of people are really confused about it, and we don't want you to end up passed out drunk in a Data's parking lot by being overwhelmed by all of these different buzzwords in there. So I'll try to level set what they are, what they mean, and then how they can help you with your particular needs at your company. What is a data warehouse on there? It's collecting large amounts of data into a single version of the truth that can include many different subject areas on there. This is not an OLTP. This is a write once, read many type of solution. When you look at data warehousing, there's a lot of reasons for it. I'll just touch on a few here. The biggest is reduce stress in the production system. So copy the data into another location, query that data instead of cannibalizing the production system. I was a DBA for many years, and I became very familiar with the kill command in SQL Server because we had a lot of problems whenever an OLTP system was also used for reporting, with queries going amok and causing people to complain that things are timing out when they're trying to read, write, and update and delete records in there. You can also, in the data warehouse, optimize it for reads on there, something that could be troublesome if you try to do it in an OLTP application in there. You can rename things. If those are familiar with ERP systems, sometimes they have really weird names of tables and fields like T116. I can copy that over into a data warehouse and rename all those fields so it makes it easy to query that data. And the idea is to have self-service BI, make it so easy that somebody can go use a reporting tool and just drag fields from the data warehouse onto the workspace so they can create reports and dashboards without having to know how to join the data, what those columns mean in there. That's the whole goal of a data warehouse. And by creating that data warehouse, you're cleaning the data, you're mastering it, you're creating hierarchies, you're doing things to make it much more easy for that self-service BI. You have that one version of the truth by collecting it all in one location, so there's no arguments about what is the actual correct numbers because you may be getting it from multiple different areas. And then the last thing I'll mention is it protects against source system upgrades. So if I copy all the data and the source systems change, if I'm running reports against those source systems, which could be hundreds of different reports, and it's upgraded and they change some of the table names, all those reports could break. Well, if I copy the data into a data warehouse, have everybody report off of that, if the source system changed, the only thing that may have problems is ETL to copy in the data warehouse, but those reports will still work. You'll just have to update the ETL. So that's another big reason for having a copy of the data in a data warehouse on there.
Those are all such great points, James. And it's funny, group data warehousing has been around for decades, and I'm still seeing, organizations, building reports directly off source systems, or off their transactional databases. Yeah. I feel like we're still like early on somewhere in this maturity curve. Something hasn't got through, but those are all such fantastic, value props. It's exactly why data warehousing makes sense.
Yeah, and sometimes when I present, I talk about use cases I've seen where people say this is a data warehouse when it's really not. And the biggest one was somebody would copy the OLTP application databases and put DW in front of the table names and say, oh, it's a data warehouse. No, that's not data warehouse. You have to do a lot with the data to organize it in a fashion that makes it for querying in there and not just copying it over with DW in there. So A lot of sometimes it's changed a lot. Now I deal with a lot of the bigger companies who are familiar with data warehouses, but certainly some of the smaller companies need an education sometimes on what is a data warehouse and what are the benefits for it. So hopefully most of this makes sense. And I have a link to my blog that talks about this some more. For those of you on the call who are data architects, and I am and have been a data architect for a long time, I feel like our job is sort of understanding all of the technologies and concepts and creating a solution with it. In this case, some data warehouse. No matter what data architecture you're using, the idea is still to gather the data so you can make better business insights and make better business decisions on it. So this is kind of what our job as a data architect look like. Now, I'm going to talk in this presentation and mention a handful of Azure products on here, but there's a lot of stuff I'm not going to mention on here. And this is just an idea of things I'm not going to mention on here. So I'm trying to show you how complicated it could be to build a data warehouse. There is no easy way. There is no shortcuts. You can have shortcuts with certain tools and some platforms and such could make it easier, but it's still a long and drawn out project to build a data warehouse, and it never ends. Once you come out with a data warehouse and you show the art of the possible and the way you can get more insights into your data, the end users are going to want more and more data in there. So they're going to continually ask for more data that you got to ingest. And that's why it's important to have a data architecture that can support a large amount of growth going forward. Growth in the size of the data, the type of the data, and the speed of the data. There's also, well, I'll talk for, you saw a handful of concepts on here. There's a lot of concepts I'm not covering in here. And this is a list that I've made up over the years of things that I've talked at times to customers about. To go more in detail about some of the data architects, you need to cover some of these topics in there. So there's so much that you need to learn to be effective in building a data warehouse, that our job as an architect is more like this, understanding all of these pieces and trying to build that solution. And through this presentation, I try to give you some clarity on some of these topics, so you at least know where to start and go down that road and pick the right road from the beginning. And therefore, you can have a successful implementation, whichever direction you take. When building a data warehouse, I find sometimes customers just dive in and they start building them without having a good idea of requirements, without having to ask a lot of the questions that are on here that you should always run through, whether you're building it on for your company or you're consulting building for others. Go through these questions and make sure you understand the answers to this, because so much is going to depend on these questions. For example, what's the skill set of the people that are building this? If there's all these products to recommend, I'm going to ask, what products you already know, and then focus on those for your solution. So I don't ask you to go and learn a whole other technology in most cases on that. What type of data do you have? Are you trying to do predictive analytics on that? Do you need to master the data? What's your budget and timeline? All these things that come into play, because in an ideal world, I can get up in front of a customer and say, I understand what you're trying to build. Here's the optimal solution for it. But most times customers go, well, that's great, James, but that's too costly. We're willing to sacrifice performance for lower cost. Well, now you need to make adjustments. So you need to ask those questions so you're satisfying the needs of the customer or your company, including pricing and cost.
Never sacrifice the planning, because I always see that get sacrificed first. And I'm like, why? Just plan, like get a roadmap in place, because there's so many hidden costs aside from the cost you're going to pay for building the data warehouse, and those never come into consideration. And I think it's well worth going through that planning phase, really being able to communicate where those hidden costs are coming from, because as soon as you see that bottom line figure, yes, you're going to get sticker shock. But what about all the other money you're spending, manual cleaning or getting the exports, data silos? There are so many things that your organization is dealing with, but it's hard to put the dollar figure on.
Yeah, and that's a good point, especially the one you mentioned about data cleaning. That's the one area more than any other that I see customers not spending enough time in. I've been at plenty of customers when building a data warehouse and I'm collecting the data from the source systems, And I say, we need to clean the data. And they go, no, it's all clean. And I said, I will bet you $100 right now that I'm going to find some problems with this data. And I've never lost that bet, because it's always, well, why are birth dates in the future? Why are people's ages 200? And because somebody was doing something in the source system to get around data entry. And the data needs to be cleaned on there. And too often the customers don't spend enough time. And then what happens is they come out with that first report, and then user gets it and goes, wait a minute, this data is not correct. Or they haven't mastered it. Why are there duplicate customers in here? They should be together. Now you immediately lost their trust. And anything you do after that, they're going to have a hard time convincing them that it's correct. So clean the data, work with the end users to make sure you cleaned it properly, the numbers are valid, you're mastering it, all those things. And make sure in your project timeline, you put plenty of time for cleaning, mastering, and verifying the data. Data warehouse history. Many years ago, the late 80s, aging myself, but that's when I started. I was in 1989, I still remember getting SQL Server in OS2, version 1.0. And the data warehouse concept has been around even before then. And the idea of collecting all this data and putting into data marts. So the data warehouse could be all the data, and then you put data marts, which were individual subjects. So kind of a subset of the large enterprise data warehouse was done in order to get performance, usually out of a subset of the data on there, and have those data marts. And MPP technologies came around, massive parallel processing, so Teradata and Netezza. When I started at Microsoft, was it 9 years ago, Parallel Data Warehouse was our on-prem MPP solution, which is now morphed into the analytics platform system. But that technology allowed you to query data that could be extremely large and do it 20 to 100 times faster than a regular SQL Server SMP type of technologies. Then this thing came around, Data Lake, which is only 11 or 12 years old. And I still remember customers coming to Microsoft and saying, hey, this data lake's awesome. We're going to put everything in a data lake, and we're going to get rid of our relational databases. And they felt like this data lake was this land of unicorns and rainbows, and you just put the data in there and it magically comes out. Well, that failed miserably. And I saw a lot of people who were involved in projects that just were complete disasters, because they found the data lake does not simplify things. There's no shortcuts. It made things worse in a lot of cases, because the data lake is essentially a glorified file folder, and I can just dump any kind of data in there. Well, yeah, great. It's easy to put the data in there, the schema on read, but you pay the piper somewhere. When you pull that data out, you have to understand it all. And that's where they really struggle, especially if you go to an end user, hey, the data's in the data lake, go use Hive SQL and fire up a Databricks cluster, have at it. And no, that didn't work on there. So what came out of that was, yeah, there are a use for a data lake, but in context, in combination with a relational database. So we had this cloud data platform where the data would come into a data lake as the staging area, and then you can do things with it, but then you also copy some of that data into a data warehouse, which I'll talk through. So that is now still the most common solution, is this cloud data platform with a relational database and a data lake in there. Now we're starting to see changes of that with these other later data architectures I'll talk about, but that's a quick and dirty history and leads us into the topics going forward. If we look at a approach to analyzing data, we have this top-down approach, which has been the history of data warehousing, is you know the questions to ask, you do all this work up front, you create the database and the table and the fields and write the ETL, and it's a schema on write, and then you load all the data on there. And whereas the data lake is this bottom up, where you don't know the questions asked, you're just kind of exploring the data. You can just dump in a file folder and quickly query it if you have the skill set to use something like Hive SQL. And then if you find value in that, you can model it later. You can move it to the relational database side of it. So the top-down approach is great for descriptive analytics, where we're looking at the history and patterns. What happened? Why did it happen? And then the bottom-up approach is great for predictive analytics, trying to look at the future, create machine learning models on that. And if we look at data warehousing, the relational database, it uses this top-down approach where we gather requirements, we do that upfront work, that schema on right, and then we have a relational database, and the work is done for the end user so they can quickly and easily query it. The data lake, using that bottom-up approach, is we can take massive amounts of data, and this was the whole idea of the data lake up front was, if I have data in Twitter that I want to use, or if I have IoT devices, there's no way a relational database is going to be able to ingest all that data and handle it all. So let's put it in a data lake and then see if the data has value. And then maybe we, in addition to cleaning it and joining it, we aggregate it, and then we could move it to a relational database, or we can do some one-time reports and machine learning models off of it. And so the data lake is focused on that. And the idea that has been popular the last 7 or 8 years, I would say at least, is to use both together. So we have the relational databases is great for historical, and then the data lake, which is great for prescriptive analytics. But the data lake has become a lot more too than just looking at it from the prescriptive analytics part of that. There's many reasons to use the data lake. And it would take too long to go over these, so I'll just point out a few, because over the years, customers have said, well, I don't understand what's the use case of a data lake if I already have a relational database. So I started building this slide to answer some of that question on there. And I would say the biggest one is, think of a data lake as the staging area. If you don't have a data lake, your staging area is in a relational database. And typically what happens is you have a maintenance window, you knock people off, say at midnight, and you load all the data and you clean it all, and then 6 a.m. you allow people to come back on. And hopefully nothing breaks, because now people can't access the data warehouse. And if you want to do something 24/7, you can't, because if you're loading the data, it's taking all the compute up on there. And then usually you load the data and then you delete it, because you can't keep all that temporary data in a data warehouse in there. So if you have to go back and fix something and you need the older data, you're kind of out of luck. You have to go back to the source system. So if we take the data lake, the idea is I can take all that data and load it into a data lake, and I can clean it in there, and I could avoid having a maintenance window in your relational database in there. The only maintenance window you have is maybe 5 minutes when you have cleaned the data in the data lake, and then you are going to load it for that brief period of time. But all that compute power that was formerly used in the data warehouse is now used in the data lake in there. And even better is, I can use additional compute that is not available in the data warehouse, because it's got a limit in there. I can fire up, say, dozens or hundreds of clusters of compute and focus on maybe one cluster per folder inside of the data lake in there. And therefore, I can, if I want to pay more, I can quickly have that data cleaned in there. And because the data lake is just storage, there's a lot of different compute options I can have. Some of them could be cheaper than others. Within a data lake, I can also keep data for longer periods of time. I can just load it, or I can copy it into an archive or a cold format in there, so I can save a lot of money and keep that data around forever in case I need to go back. So that's just a quick and dirty reason why you have data lakes. But I find almost every case now, customers building a data warehouse are using data lakes. So at a high level, if we look at using both, we think of the data lake as your staging and prep, and thinking of the data warehouse as a serving and security and compliance in there. And so this kind of summarizes the two use cases of those, and we'll talk more about them. But one I'll point out too is also security. In a data lake, it's file or folder based in there, so there's no such concept as a row-level security or column-level security. Those things you can do in data warehousing, and they've been doing it for years. So in some cases, customers will say, I'm going to use the data lake for all that staging and prepping, but I'm not going to allow anybody, any end users, to query the data. I'm going to instead copy the data warehouse in there, because they know it, and data warehousing, they've known it for years how to query things in there, and it's got that additional security on top of that. And this is starting to blend together, as we'll see in upcoming slides, with some of the newer technologies, or making it more accessible to use the data lake, and in some cases get away with not using a data warehouse. But those are small use cases that I think will grow over time, and we'll talk through some of those in a minute. And then I wanted to point out the maturity stages. If we look at customers building a data warehouse in here, most of them are still in stage 2. where they're just now collecting and centralizing all this data. And they haven't got yet to the point of doing predictive analytics, machine learning models in there. They haven't got to the point of being able to collect data no matter what the size or the speed or the type. And that's where you want to get to build a solution that can handle any type of data and then also do predictive learning on top of that. And that's why I say stage 3 is going to be a big tidal wave coming down the road, because as more companies get through stage 2 and they use it for the historical reporting, they're going to say, now let's start using it for predictive analytics in there. And so you're going to see a lot of that in the future. All right. Modern data warehouse. So getting into some of the concepts now, and I apologize for this sloppiness. Usually at this point, sometimes I start whiteboarding, and I haven't yet converted this to a nice and pretty format. I'm an architect. I'm a data guy. I don't like to do slides, but
it looks beautiful, James. It looks
okay.
Beautiful.
People have complained about that guy. That's somebody with a hat. It's a data scientist person. It looks terrible, but when you break out what a modern data warehouse looks like, I have it in 5 stages. You ingest, store, transform, model, and visualize the data. And most anybody who's building a modern data warehouse, we're talking about it, has these 5 stages. Maybe they rename them a little differently. But the idea is you can have many different sources. In stage 1, you ingest it. And in green here are, if you're using Azure, you would use some of these products like Azure Data Factory to ingest it. You would store it in a data lake. In Azure, that's Data Lake Store Gen 2 in a raw format. So the data lake has many different layers in there. Raw, and then you clean the data and put it into a clean layer. And then you may join the data and master it and put it into a presentation layer. Maybe you make a copy of the data and have a sandbox layer on there. And then within that data lake and those layers is folder structures in there. So sometimes I'll spend a whole day with customers just going over data lake design. And what's the best way to lay it out? And there's no one simple solution because it all depends on type of data and the size and the speed of the data. And I haven't got into real-time streaming in this case. This is focused on batching data over across there. But the idea is you have, say, a raw layer, and then you have folders underneath it, maybe broken out by subject, maybe broken out by folders for security reasons on there. But as the data lands in there, you're going to need compute on top of it to clean it. And that's where stage 3 comes in, to transform the data. And that's where you can use products like Azure Data Factory Data Flows, which is a very visual way of cleaning and transforming data. You can use something like Databricks, which is a Spark-based notebook to clean the data, which is helpful if you need more flexibility, more features, more performance. You may want to go that route. And now with Azure Synapse Analytics, they have this serverless piece, which you can use T-SQL and pay as you go and clean the data for those that like T-SQL and clean it that way. So most times customers use a combination of these on there. I always say try to do it the easiest way, which would be Data Flows and Data Factory. It's very, very easy. It's not no code, but low code solution in there. And if it doesn't do the job, then you may want to go to something like Databricks.
And they're going to start bringing Power Query into ADF to try and help democratize that whole pipeline, data pipeline, builds.
Yeah, so Data Factory has data flows, which Microsoft loves renaming things. They were called mapping data flows, and now I think they're calling them just data flows. And then they have this other thing they were calling wrangling data flows. That's now Power Query. So now in Data Factory, you have 2 options: data flows, and I'm glad you brought this up because I should list it on here, and Power Query. So if those familiar with Power Query, if you used it in like Power BI or Excel, that is another way to clean the data. So very visual and easy way to clean it. So hey, if you know that and you don't want to get into the Spark realm, just handle it with Data Factory and Power Query.
I always tell organizations the best investment you can make across an organization is learning Power Query. For from Power BI to Excel to ADF, it's going to pay dividends as we see more and more self-service analytics take hold.
Yeah, and that brings up a point that I'm talking about many different products here. In the end, you have Power BI for the visual, but I can actually use Power BI for all of this because Power BI has Power Query, it has a data lake, and I find customers are using Power BI as a self-service ETL tool. It wouldn't be for an enterprise solution, but if you just need to do something quick and dirty, you can do it in Power BI. Or I'm starting to see customers use Power BI as the prototype tool. So instead of
Exactly.
IT going to the end users and saying, well, what do you want? And you write it all down and you go back and you build it and you give it to them and they go, well, that's not what I want. Well, that's what you said. Well, that's not what I meant. You can say, why don't you just go prototype this in Power BI and then I'll use that as my business requirements. And I find that does a lot less reduction in mistakes or misunderstandings. Plus now you get the end user to sort of be part of the building process, because you can actually take some of the things that they put in Power BI, like if they use Power Query, and you can move that in Data Factory. So you're not having to redo things that they've already done.
Yeah, and you deliver value fast too, right? I mean, you
Yeah.
can even productionalize some of those prototypes while kind of wait
Yes.
for this to happen. We've loved that approach, and that's what we typically do with all of our customers. So
Yeah, great.
love that you mentioned that.
That's the way to do it. You can get very quick wins with using Power BI without having wasting all that effort. And then step 4 in here is to move that data, a copy of it, into Synapse, Azure Synapse Analytics, to model it, and you generally copy it into third normal form. And then my chicken scratch here, you can usually copy it into a star schema. So you make it very easy for that end user that's using Power BI to drag and drop those fields and do that self-service BI, because IT has done all the work up front to make it very easy for them. They don't need to do anything about cleaning the data. They don't have to join it. It's all done in the star schema. You've all created those relationships for them. So there's the trade-off, is if you look at this, as the data gets moved along here, it's more work, it's more ETL, it's more cost. But the benefit is it's really easy for an end user to go and query that and report off that data, while still allowing in step 2 that data scientist person with the hat or a power user to, if they have the skill set, they can quickly go and generate queries and reports or investigate the data. Maybe somebody goes, hey, I have this data, I think it could be useful. Instead of you going through the whole process of putting it into a data warehouse and creating the metadata and the tables and the fields and writing the ETL, instead you just dump it into a data lake and have somebody go and query it, and they can go, actually, this is not useful at all. So I'm going to don't bother with it. Or they can go, this is useful. Let's now move it to the data warehouse, but we validated that it has value. And I'll answer some questions. Why go to third normal form and not straight to star schema? You can. This is, I would say, the most steps you would do, but you can find optimizations along the way. One of them could be go right to a star schema. I always say it's think about, though, is the challenge is it could make the code to go from the data lake into Synapse star schema pretty complicated. And it's to go to third normal form, you're trying to think of it as breaking a complex problem into 2 smaller pieces. So it could make more sense to go to third normal form and then go to star schema, especially if you're trying to do things like slowly change the dimensions and stuff. But if you don't have a large amount of data and the tables combinations are not that complicated, you can skip that step. But be aware of the trade-offs on that. And I think I have a blog that I wrote many years ago that talked about why you'd still want to have third normal form and star schema, but read through that. And if you say, I understand that, you can skip that step of third normal form. All right, getting into some of the other technologies, data fabric, data architectures. I think of data fabric as just an extension of the modern data warehouse. It's sort of a superset of that. My definition is not universal. Others compare data fabric to just the modern data warehouse I just talked about, or some compare data fabric to a data mesh. I put it in this format because it's easy for me to understand and go along, and maybe it is for you too. So take what I just explained and now add things like data access and policies on that. Create a metadata catalog that tracks the lineage of the data. Have master data management in there. Add some virtualization, real-time processing. Maybe have API calls instead of having connections to each of the pieces of the data, everything done through an API. And maybe breaking out into building blocks. So if I create, say, a data ingestion piece, I can then reuse that outside of the data fabric that I've built. Maybe somebody goes, well, your data fabric is great, but I can't use it. But you really created a nice, interesting data ingestion piece. Can I get a copy of that? So if you create it in the way that you compartmentalized pieces of the data fabric. Somebody can pull out maybe just the MDM piece or just the data access and policy piece on there. So that's the way I think of a data fabric, as an extension, sort of the next generation of a modern data warehouse. But I'm open to people having counters on that. But the thing is, at least if we level set these different types, whatever you want to call it, name it, there's an understanding of what they actually are. The data lakehouse has come about, and this last piece is the idea is, can we go back to the late 2000s data lake and once again said we don't need a relational database anymore. We can just use the data lake. And well, what's changed since then is a layer that you can put on a data lake called the Delta Lake. This gives a data lake features that are typically only in a relational database, like ACID transactions. So you have the consistency in the data lake by having that and not having people query and queries changing on the fly because data is being dumped in a data lake. The Delta Lake will take care of that. It has a thing called time traveling where it versions the data as it's put in there. So you can always go back in time and see how things were and create an audit trail with that. It has an environment that you can stream and batch at the same time using just the one technology on there. It's got things like schema enforcement. So if you dump a file in a data lake that is different fields than others in there, it won't just bomb out your queries in there. It'll reject that and put it into a different folder on there. And then there's a lot of performance improvements by the ability to do upserts, inserts, and deletes much more quickly than a traditional data lake. So the idea is, hey, we can now use a data lake and avoid using a relational database because of the Delta Lake technologies on there. This is heavily pushed by Databricks. And I would say, oh, yeah, this is an option, but still limited in the use cases. And even Databricks will say, this is not for everything. This is not like the previous disaster with a data lake. You can have, and I agree with you, there can be more use cases than before where you can use a Delta Lake and not have to use a relational database. And also with some of the changes in Synapse, it's allowing you to use a data lake as your one source. And to quickly point out, that is with a Synapse, you can use regular T-SQL over data sitting in a data lake, or you can use a data lake, a Delta Lake 2 within Synapse. And that was the biggest challenge with a data lake before, was if an end user is used to T-SQL and you say, hey, go and use data in the data lake, but you have to use Hive SQL or Spark SQL. That didn't fly well. Well, now Synapse allows you to use T-SQL on that data. And so now that will allow more use cases of people going, maybe I can get away with just using a data lake or a Delta Lake and not have to use a relational database. So the use cases for data lakehouse are the reliability in keeping the data lake and a data warehouse consistent. If you have them, both of them there could be some times where they're not equal in there. And there could be staleness because the data in the data warehouse could be older than what's in the data lake. There's not great support compared to a data lake for ML solutions. Most of them work really well on a file folder structure, that structure that you have with the data lake, and not so well relational database. And then finally, another reason for using a data lakehouse is that you're saving costs, at least in theory, by not having two copies of data, one in the data lake and one in the relational database. And I should mention the data lakehouse term came about because you have a data lake and a data warehouse and put them together and you have yourself a data lakehouse. But the concerns over skipping the relational database I touched on before is one is security. There's no row level security or column level or dynamic data masking in a data lake. Now there are workarounds and there are products you can do to do that, but then you're adding more complexity, more cost, and you're still copying the data to make these features available. So if you're going to do all that, why not just put it in a relational database? The relational databases are always going to be faster, especially because you have this MPP technology on there, which could be okay. Maybe it's okay if a query takes 5 seconds, but if you need it in 50 milliseconds, you're not going to get that in data lake. So you'll want to have a relational database. And there's just missing features in there, and people are used to relational database. And the last thing I'll point out is the complexity. If I have a data lake or a Delta Lake, and I'm ingesting many different source systems, so I have many different folders, many different layers in there, it can get very complex to try to query data sitting in that format, because the metadata is separate from it. You could have metadata within the file or some separate file on there, but it's much different than looking at a relational database where you see the metadata first and then the data. In the data lake world, it's not like that in most cases, so it can get very complex on that. So you got to be aware of these concerns. Not that you couldn't use just a Delta Lake or data lake in there, just be aware of the trade-offs.
And quick question, James, and time check. Is this a good point to ask the poll question? And we've got
this was it. Perfect, yeah.
Oh, perfect. Okay, so we have our second poll question. In your company, which one of these architectures that James went into great detail about do you believe is being implemented? And if you don't know, all good. But it would be great to have an understanding, kind of where our organization's heading, what have they invested in so far, and what is maybe still out there as just kind of concepts and waiting to be productionalized. Oh, we've got a data fabric. Okay. We've got one. I like saying the data lakehouse. I mean, I think it's just a term for something. I mean, to your point, organizations are already doing, using a data lake to stage and then move to the data warehouse. And we just, slapped a term on it, right? We got some traditional data warehousing. We got data mesh votes as well. Okay. That's awesome. But I would say majority are still in the traditional data warehousing space. We're breaking into the data lakehouse, and looks like we're still early on in the data mesh and data fabric. So thanks everybody for responding.
Yeah, that's good. Very interesting, and pretty much what I expect. Data lakehouse is starting to see more and more of those as those use cases become valid, especially with Synapse in there. And the data fabric, again, you can say that really is just a traditional data warehouse, just glorified. And then the data mesh, I honestly see very few people who've implemented a data mesh. Some of them are trying to implement them, and we'll talk through what are the concerns about that in a second. So here we go, data mesh. The big difference in a data mesh is the decentralization of the data. So the idea is, instead of copying all the data in one central location, we keep the data separate outside, and we create what's called these data domains. But decentralization is the big feature of the data mesh. And I'll point out that data mesh, which has been around just a couple of years with that title, the data mesh concepts have been around for quite a long time. It's just more of centralizing the concept into a cool term called data mesh. And when we look at what the four or five pillars of data mesh is, the ownership is now decentralized in there. Instead of copying all the data into one location and saying IT owns the data is kept outside of a central location, and the individual domains, HR, payroll, operations, they all own the data. The pipelines, therefore, are less important because you're not copying all into a central location on there, so less ETL. Data, instead of it being sort of a byproduct, you think of data as a product on there. So each of the domains are going to given essentially a contract of how they're going to clean and master and present the data. And that's where we have the data infrastructure as a platform. Is IT would give the standards and guidelines for all the domains that they would follow, so that they are all being consistent in how they are cleaning the data and governing the data and presenting it. The other big change in data mesh, which is organizational change. Data mesh is not a technology. It's just these concepts. Now, how you implement them are a big debate. And I always say well, I'll get that in a minute. But the challenge is, okay, with IT, if I'm ingesting all this data, IT becomes a bottleneck, and they may not be able to scale. If I then instead have each of the domains have their own teams, I can scale, because now I have, each time a domain comes up, I just get more people that are inside that team and are doing the things to make the data a product on there. So I can scale much better, at least in theory, by having the data mesh concept of domains in there.
And I've seen organizations kind of do this, already, not even kind of subscribing to data mesh, but having their own like shadow BI or IT teams for their business domains. just because, IT still has a stranglehold on it, but we're trying to do as much as we can to kind of relieve that bottleneck. Some organizations I think are actually trying to implement data mesh, but don't even really know it.
Yeah. And I say, if you ask 10 people what a data mesh is, you'll get 15 different answers. And that's one of the challenges with the data mesh is nobody really knows what it is. And a lot of people who are building it are having exceptions to the ideal data mesh in there. So if I'm not following all these, is it really data mesh? I don't know. And so the use case for data mesh is trying to solve these challenges with a centralized data lake or data warehouse. Who owns the data? Who is responsible for cleaning the data? And the fact that the domains know the data best, they should be the ones responsible for cleaning it because of that. The scaling, as I meant, not having that central team becoming a bottleneck. And then the technical scaling, the idea that the current big data solutions can't keep up. And therefore, we need this data mesh. That's the theory part.
If you don't mind me making this point, what you were mentioning earlier, around the data lakes, you're doing all your cleaning, it's all a one-way street, from that data lakehouse perspective. But when you use data mesh and the business domains actually owning that cleaning, they are the ones that have a better purview into, oh, here's how we can get back to the source, or use off-the-shelf solutions, like a CDP that can push data back to the source or push it forward. That two-way street has to be, it's going to be people and it's going to be platform, it's going to be a process, right?
Yeah.
And they're going to be the ones best to own it, because when you leave it to IT, they're going to be like, screw it. We're not going to spend the time to go tell HR that, this one single individual keeps putting, 99999 for birthdays or something. But if HR is the one actually owning, like, oh, wow, yeah, it's a short circuit the path, right? And the cost it takes to get to that path.
Yeah, so that's a good point. And while data mesh sounds great in theory, there are a lot of concerns with it. And I've listed some of them here. And these are probably only a third of the concerns I can put on here. And I mentioned some of my blog and could write another blog on concerns. So I don't want to be too negative about data mesh. I have seen some use cases for it, but they're pretty rare. And I'm fine with somebody going to data mesh if they go through these concerns and they come out at the end of it going, yeah, that's fine. We can still do a data mesh on there. It's if those people saying, oh, this sounds like a great buzzword, I'm going to go and use build a data mesh, and they get halfway through it a year down the road and they go, oh, well, this is not working out. I wasn't aware of these issues with it. And so I tried to list some of those issues to educate people. And I'll say the biggest one is organizational change. In your company, can you go to all the domains and tell them, you're going to now follow this contract, you're going to clean the data, you're going to master it, you're going to present it in this format, and you're going to do all that extra work. And they're going to go, well, why should we do all that extra work? And you're going to say, for the greater good of the company. Can you do that? And what happens if there's 10, 20, 100 domains? And all you need is a handful not to agree with what you're doing. And they're going to go, we're not doing that. Now you have outliers. How are you going to handle that? So you have to think through these things. Now, I've had some companies that go, oh, yeah, we're really open to change. We think we can do this. And others go, there's no way in the world I'm going to get people to agree on this. So you have to be, that's a big concern to have in there. Other things here I'll just touch on is performance reasons in there. Now, if you have all the data out separate and not centralized, and I need to query that. Now, I'm going to query it, and I'm going to join those different data domains in there. It's unlikely you're always going to have to do that in some case. Somebody's going to have a view across all domains. Well, how am I going to join all that data together? Well, if it's all separate in there, I have to use what, virtualization software maybe for that, and that's going to have performance issues with it. So, and part of data mesh is saying you can aggregate domains in there, which is kind of bizarre to me because that kind of go against the main theory of data mesh is keeping everything separate. Is now you're saying you have domains that you combine the data and aggregate it. Well, then who owns that? So now you're having that argument of ownership when, so that's some of the things I have real big concerns about data mesh is some of these exceptions to it. And then what we're finding is people going, yeah, we can't get the performance needs. So we're going to centralize all the data and put it in a data lake. And maybe, yes, you can keep the same ownership. We're just going to have a folder for you and you own that. And so, okay, maybe that's a good middle ground between a data mesh in theory and a data mesh in production and being built out. And I would say the last thing on here is not seeing the big picture for combining all this data on here. all the domains are just concerned about what they need, and it's just their subject matter. They're not thinking about how well this fits together with other pieces of domains. So maybe they clean the data and they do it in a way where it doesn't line up with the way other people cleaned it. Or maybe performance reasons, they do it in a certain way. And you're going to need somebody to combine all the data, and you're going to still need people who know all the data so they can combine it in the most performant and logical way of that. And so that needs some central IT to be doing that. So if you're getting away from central IT, there's more reasons that you need a central IT, and that's to see that IT, that's to see the bigger picture.
Or central BI, right? I almost see the central BI team as that, like that top layer, right? And then maybe you're kind of trickling down with some of the more like, democratized data domain areas where they have like their shadow BI person or their one data analyst who became the Excel gun and now is doing Power BI, right?
Yeah. And kind of add on to that is with the data mesh, you have all these data domains, and each of them has their own IT-like people building out so you can scale. Yeah, good luck in finding a lot of technical skills. I'm finding the best, especially
Totally.
with COVID, it's just to find the talented people, and it's just a nightmare. And then now you're gonna have people who may not be experts, and so I kind of disagree with being this cross-functional team. I think it's still better to have experts in each of the different areas to work together. And if you're gonna have, you can't really do that in a data mesh because you're just not gonna find the people on that. So that's the other big challenge. So again, it sounds great in theory, but going to and practically implement that, you're gonna find a lot of these concerns are justified.
Totally.
And then some of the things I pointed out, but if you're going to build a data mesh, I think you really need to have current pain points. If everything's running pretty good, just don't go, oh, let's switch to a data mesh because it sounds really cool. Do you have problems with the data and collecting it all and getting accuracy on there? Are things getting away from you? As you pointed out, are you having a lot of these shadow IT propping up? Well, maybe a data mesh could solve some of those pain points that we're having. Maybe you are having big pain points in scaling, which is a big problem I have with data mesh, is that they're trying to say, well, technology doesn't scale, and that's why you need to go to data mesh. I disagree with that. I've been at Microsoft 8 years. The technology is getting better and better on that. You look at Synapse and all the amazing things that does on there, all the MPP technologies that come out there, or Microsoft internally, they have a data lake that they've built that's many petabytes of data. So you can scale this. So it's not, sometimes I feel like data mesh is trying to solve problems that don't exist. They're just overly dramatic on not being able to scale. And that's the reason that data mesh says why projects are failing, data warehouse projects are failing. But I say it's more of not the technology, it's the people and process we put in place, or just choosing the completely wrong technology when something out there is better. And that's the reason it's failing, not so much a scale problem. And then lastly, I wanted to point out was the question was, what, for those doing data mesh implementations, what are the industries? And these are links to videos that you can see of people implementing the data mesh. The one thing you'll see is this is not like, hey, we built a data mesh in 6 months. This is mostly, we've been working on it for a year and a half, 2 years, and we're almost done with it. So don't think data mesh is going to make things shorter to implement. It's going to take things longer on that. But the ones that have built out and have been successful, and a lot of large banks, and I think that's because it's easier for them to create those data domains, and it's more easily fits in these boxes than other companies where some of these domains in other companies may be a mishmash of really dozens of domains in there. And now you have to break them all apart, which is a lot of work, which maybe the large banks have already done. And then you also notice these are big companies. This is not, a data mesh can be huge overkill if you're a small company and don't have a lot of data on that. So I would go against just saying, hey, let's start from the beginning of a data mesh, even though we're not a big company in there. It's probably going to be way overkill, and why not just do a traditional data warehouse or a data fabric, and that's going to solve most of your needs, and it's going to do it a lot quicker than going the extra route of taking a data mesh. All right, so that was essentially where I ended.
We made time. I'm so impressed.
Yeah,
this never happens.
I've been very good at that. I did a couple in this deck, which I think you'll make available, is
yes.
Sometimes I get questions, well, what is a data fabric versus a data mesh? So I have a couple of slides in there that go more into details on comparing the two, because there's there's some people like Gartner will say a data mesh and data fabric are the same thing. Well, I like to break them out into different categories, whatever you want to call them. You can rename them to anything, but understand that these are different data architectures out there.
Do you want to spend just the 2 minutes before we get into Q&A? I don't know if we can stay on maybe an extra 5, but just
Yeah,
really.
I can go an extra 5. Yeah, so this compares the two on there. And I would say the big thing, a lot of them is the governance on there. And the data fabric, you copy all the data into one location, you run your data cleaning on top of that. In data mesh, you have many data governance layers in there. IT can say, this is the way you should govern and clean the data. IT could say, look, for states, use abbreviation of 2 digits, not the whole thing, because you don't want people having different ways of cleaning the same data on there. And that's a challenge, because now you have multiple areas where data is being governed, and all it takes is one person to not do it the right way, and you could have all these problems trying to join the data together. The other thing is I'll point out is the security on there is, again, you copy all the data, you have one security on top of that. If you have data that's kept separate out in these data domains, are they applying the right security? IT can say this is the security that you are going to use, but are they applying it? And how are you going to govern that? Are you going to have now people that have to go look out for what they're doing? Well, now you have an IT staff that's got to make sure everybody's following what you said on that. So they have that complexity on there. And again, all it takes is one data domain to go, I'm lax in security, I'm not going to do what you say, and they get hacked and their data gets exposed, and you have all sorts of these problems.
Perfect. Well, we're right at 12. We do have a couple questions, and I think I'm going to bubble up this one. And I think, I mean, you did answer this, but maybe worth reiterating, you know, isn't data mesh just decentralizing the effort into individual areas? Isn't this going to make organizational reporting and analytics more difficult? And that's where I think you had mentioned, you know, there's kind of 2 tiers, right? You have data domain level reporting, then you have like higher level, you know, where you're bringing all of that together, typically with a centralized IT team.
Yeah, it is difficult, and it is challenging, and you have to be open to change in your company, and you have to have the skill set in each of those areas to make sure they're implementing what you usually typically a contract. This is the way you should do things, and make it as data as a product, and make it accessible in this particular format in there. And then that causes performance problems if all this data is separated and centralized. And so that's a huge concern. And then the other thing is, if you have these individual data products on there, and some of them go, look, I don't want to do all that. Just take my data, do whatever you want with it. I'm just focused on getting my area working and there. And so you're gonna have a lot of pushback from people to not want to do the extra work. So then what do you do? And what I'm starting to see is a combination of a data mesh, data fabric, where in certain areas they'll have a data mesh, but other areas will be more like a data fabric where they're centralizing it. Now you throw in virtualization software in there, and that's another layer. And that's what one of these slides were. If I implement virtualization, how is that different from a data mesh? And I point out that usually you're just virtualizing some of the data and not all of it, and in a data fabric. And then you're not making data as a product. You're not giving them contracts. And the ownership is still usually with central IT, even though it's virtualized. Many times it's virtualized just for, we got to keep data in a certain country. We can't pull it out. So we only pull it out if somebody's in the same country, that kind of thing. And you still have those data engineering teams that are in IT and not spread out among those various data domains.
Makes sense. Well, we did it. And, you know, when we're on Teams, I know people can come off mute and do their reactions. Well, we're not on Teams, we're on Zoom. And so I'm going to be the one giving you your round of applause. I don't know if Tina or Joel can come up and just like join me in doing it. But either way, James, I'm so thankful for you and just spending this time with us, you know, really helping kind of clarify these terms, these architectural decisions organizations are making, and, you know, really understanding it's a journey. No matter the way you cut it, you know, there's going to be value propositions for different things. Do spend the planning, you know, spend the time to plan and find those high value areas. And again, just thank you so much for your time.
Yeah, and I'm sure in a few months we'll probably have some other buzzword like power mesh or something related to that I'll have to talk about too.
Well, we'll get you back on. So we
Yeah.
know where you're at, and hopefully we get the chance to do a webinar again in the near future. Wishing everybody happy holidays, staying healthy, staying safe, and hope to see you again sometime soon.